Hey guys, we're doing multiple choice 103 to 106. All right. So, question number 103. You already have the answer. Let's see, where is it? You already have the answer C. So let's see why though. Okay. So it says an athlete suspected of steroid use is given 2 tests that operate independently. So if they're independently, we can multiply them to find their probability. So it says test A has a probability of being positive of 90% if steroids have been used. So probability of a given steroid, right? All right. And then it says test B has a probability of being positive if the steroid has been used of 0.08. So we worked through this today. Either you use test A or test B. Either you test positive or you test negative. Okay. What is the probability that neither test is positive if the athlete used steroids? Okay, so all of this is given that they use steroids, this chart. So let's see. What's the probability that neither is positive? Okay. Okay, well, hold on. So this would be the probability that you're not positive with A given you use a steroid has to be this. And this would be the probability of not testing positive with test B given you use the steroid. And so if they're completely independent, those are just using the complement rule. If those are totally independent, I should be able to multiply them. And I get 0.02. So that's how I get this answer right there. Now, it looks like maybe, like I said, this is a little messy. Math gets a little messy. We may have to use a couple different strategies till we settle in on the right one. Okay, 104. This one you don't have the answer for, so let's figure it out. It says, in an effort to find a source of an outbreak of food poisoning at a conference, a team of medical detectives carried out a study. They examined all 50 people who had food poisoning and a random sample of 200 people that attended the conference who did not get food poisoning. The detectives found that 40% of the people with food poisoning went to a cocktail party on the second night of the conference, while only 10% of the people in the random sample attended the same party. Which of the following statements is appropriate for describing 40% of the people who went to the party? Okay. Let F be food poisoning and let A be attended the party. Okay. So let's read it over again and figure out which one has the right notation. So it's saying the detectives found that 40% of the people with food poisoning, 40% of the people that got food poisoning, so given that you had food poisoning, All right. Given you got food poisoning, what's the chances that you went to the cocktail party? So we know that this is attended the party. Given that you got food poisoning. And that one matches, let's say which one it is, E, okay? Yep, that's the proper notation based on the way the wording of the problem. Nice, okay. Now, 105, we see in the back of the book our answer is E. So let's see how we got this. Okay, so here's our probability space. All these have to add up to 1. And it's saying if this die is thrown and the top face shows an odd, so this would be odd. What is the probability that the die shows 1? So if it is thrown and shown as an odd, so given that it's odd, right? So I want to put given that it's odd, what's the probability, given that it's odd, that it's a 1? Okay, so there is, how many of these were odd? So again, if I think of this out of 3, 4, 5, 6, 7, 8, 9, 10. If I think of this as 10, 3 of them, and 1 of them, and 1 of them. So 3, 4, 5. 5 of them were odd, and 3 out of the 5. And that equals my ratio. And that was using logic, not a formula. I could have also kind of used this concept of formula and added these ratios together and still gotten the same answer. So this is the probability of getting a 1, and this is the probability of odd. I added those up. Okay? And it's equal to the probability of 1 given odd. 106. This one you don't have the answer to. But so let's work this out together. So it says the probability of A is 0.24. And the probability of B, A and B are independent events. So we don't know what A is, but they're independent events. So that means this would be not A, and this is B, and this is not B, right? So this would be 24 out of 100, and this would be 52 out of 100. So kind of using the complement rule here, we can kind of look at this. This would be 76, okay? So this is kind of what's happening, but they're saying that they're independent events. So that means that the probability of A is equal to the probability of A given B, given that B happened. So what has to be, they're asking, what is the probability of A or B? So if we added these up, right? So that would have to be A or D. I could add 24 to 52, but I have to be careful with my overlap, right? But they're independent events, so there is no overlap, right? So that would mean well, no. I could have hold on. They happen at the same ratio, is what this is telling me. So let's see. I have, if they're independent, then the probability of them happening at the same time If they're independent events, this should just be the 2 multiplied together. So this is interesting. So let's see what this ends up being. All right, so the probability of A and the probability of B. And take away the overlap. So let's just do a little quick number crunching. And actually, you did it. I actually used, instead of using kind of a table, I actually used the formula. And this does happen every once in a while. There is a problem where I'll use a formula and it seems to make more sense. Okay, cool. And I got my answer C. Thanks for joining us, guys. Good luck studying for the test.